Hello students, and welcome to section 7-6, factoring ax squared plus bx plus c. So we've already discussed factoring x squared plus bx plus c such that a is equal to 1. Today we're going to be taking a look at when a is not equal to 1. First example, factor out a common factor. What is the factored form of 3x cubed plus 15x squared minus 18x? So if we take a look, it turns out that we do have a GCF, or greatest common factor. Before factoring the trinomial into two binomials, look for any common factors that you can factor out, GCF in particular. So as it turns out, there is a common factor of 3x, and you can see that start to take shape, noting that 3x cubed, 15x squared, and 18x, technically negative 18x, right? But 18x on its own have a GCF. So 3x cubed can be factored as such: 3x times x times 3x times x times x, or 3 times x times x times x. 15 is 3 times 5 times x, of course, x squared. And then 18x is 2 times 3 times 3 times x. So what's common between all three of these? We see a red 3, we see a blue x, and that's it. The GCF here, or common factor, greatest common factor more specifically, if you recall, is 3x. So what we do is we factor out the 3x, as they show right here. Now when you factor out the 3x, really factoring is the same as dividing. So in a sense, you're dividing 3x out of 3x cubed. 3x cubed divided by 3x is x squared. 15x squared divided by 3x is 5x. And then negative 18x, include the negative in your division. Negative 18x divided by 3x is negative 6. If you're unsure about this, go ahead and distribute to prove out that yes, 3x times x squared is 3x cubed, 3x times 5x is 15x squared, and 3x times negative 6 is negative 18x. Then factoring the expression x squared plus 5x minus 6, factoring as we knew from back in the last section, or remember from back in the last section, where we want to find two numbers that multiply to negative 6 and add to positive 5, if they even exist. As it turns out, c is negatives, again negative 6 being our negative c value. We know that the factors of negative 6 are many, and then the sum of the factors, though, we have to pinpoint to be 5. For example, 1 and negative 6, although 1 times negative 6 is negative 6, 1 plus negative 6 is negative 5, and we wanted it to be positive 5. So we proceed with a different number pair. So negative 1 and 6, yes, those multiply to be negative 6, and if you add them together, negative 1 plus 6, of course, is 5. So because c is negative in the trinomial, the factors will have opposite signs, as we've discussed in the past. And we are ready to finalize our answer in such a way where not only have we factored out the GCF, but we also now have this binomial times this binomial, x minus 1 times x plus 6. So the full factored form includes the GCF, again from the very beginning, 3x, times the quantity x minus 1, times the quantity x plus 6. This is the full factored form of this cubic trinomial. We call it a cubic trinomial because there's a third degree and there's 3 terms. Example 2. Understand factoring by grouping. If ax squared plus bx plus c is a product of binomials, how are the values of a, b, and c related? Consider the product of 3x plus 4 and 2x plus 1. So we remember hopefully how to FOIL this. We can do our foiling as such. So first, 3x times 2x, outside 3x times 1, inside 4 times 2x, and last 4 times 1, which lends itself quite nicely in the next step to 6x squared plus 3x plus 8x, and then of course there plus 4. As we continue, adding your like terms in the middle, 3x plus 8x is 11x. So here's your next step. The product of 6x squared plus 11x plus 4x is what we are yielding or getting as a yield from those two multiplied together. That is the product. And notice as they suggest A times C, right? 6 times 4 from, in this case, we've got these two numbers, 6 times 4, or 3 times 2 times 4 times 1, which stems from the values that we see in red up above, 3 times 2 times 4 times 1, which is the product of all of the coefficients and constants from the following. So again, 3, 2, 4, and 1 are in fact the product of all coefficients of the constants from what that initial setup took shape as. In the middle step, the coefficients of the x terms, 3 and 8, add to form your b value of 11, which we've done in the past. They are composed of pairs of the coefficients and constants from the original product, 3, which is 3 times 1, of course, and 8, which is 4 times 2 from the prior step, 3 times 1, 4 times 2. In proceeding, if ax squared plus bx plus c is the product of binomials, there is a pair of factors of a times c that have a sum of b. So we're going to go ahead and continue this idea where, again, we do know how to factor yielding our sum and our product, looking at our prior tables. But we're going to continue by this, again, this approach wherein we see really the grouping about to take shape. So let's take a look. How can you factor ax squared plus bx plus c by grouping? Consider the trinomial 6x squared plus 11x plus 4, as we saw in part A again, where a is 6, c is 4. Therefore, ac is equal to 24, 6 times 4, of course. Find the factor pair of 24 with a sum of 11. Again, something we've done before. In this case, though, remember, 6 and 4, a times c, giving us 24, is not necessarily as easy as just saying 1 times 4, for example. On the problems in the prior section, we did see a equal to 1. Now, because it's not 1, well, we're not just getting c essentially, we're getting a times c, which is, of course, 24 here. The middle number is the same. In other words, the sum is still what we want it to be. So let's move on. So we want factors of 24, where we want from there the sum of factors to be, well, 11. In the first case, they chose 2 and 12. 2 times 12 is 24, but 2 plus 12 is 14, not 11. So let's pick two other numbers, 3 and 8. If you pick 3, 3 times 8, of course, is 24. 3 plus 8 is 11. Rewrite 11x as 3x and 8x. So here's where the problem gets a little bit more interesting. We have not yet seen a problem where we're going to take the sum using 3 and 8 and attach a variable. By attaching a variable, you're basically highlighting the idea that 3x plus 8x is 11x, which if you look back at the original problem was the middle term, 11x. So we are literally going to take the middle term and rewrite it as 3x plus 8x as you see in the next step. So rewrite the problem as you see. And by the way, this is also called splitting the middle term. We are splitting the middle term of 11x into 3x and 8x. Again, splitting the middle term. In the next step, we can actually group. Factoring by grouping is the process in which we put parentheses around the first two terms. There they are, around 6x squared and 3x, and around 8x and 4, so parentheses 8x plus 4. Factoring by grouping, which leads to another GCF analysis. Between 3x and 6x squared, there's a 3 as well as an x in common, so there's your GCF. When you factor out a 3x out of 6x squared, you're left with 2x, and out of 3x, you're left with 1. Similarly, as far as these two terms, you can factor out a 4 as your GCF, which leaves you with 2x. 8x divided by 4, of course, being 2x. 4 divided by 4, of course, being 1. The beautiful thing about these two sets of parentheses, which they have marked in purple, is that they're identical. And because they're identical, you know that it is in fact properly factored. In the next step, you have another GCF. Turns out because they're the same, you can factor it out. 2x plus 1 is factored out of both, and you're left with what's in red, 3x plus 4. This is the factored form. And as far as highlighting it with also some check steps involved, yes, 6x squared plus 11x plus 4 is this, 3x plus 4 times 2x plus 1. The order doesn't matter. In other words, if you put 2x plus 1 first, that would be fine. 2x plus 1 times 3x plus 4 is the same answer. As a check step, however, if you were to FOIL those two binomials, you will end up with this in the next step. And then, of course, that in the final to check out that, yes, this checks out to be that original quadratic. Let's move on. Factor a trinomial using substitution. So how can you use substitution to help you factor ax squared plus bx plus c as the product of two binomials? So in this example, we'll consider the trinomial 3x squared minus 2x minus 8. Step 1, multiply ax squared plus bx plus c by a to transform it into ax squared. So as you take a look, 3 times the quantity 3x squared minus 2x minus 8, multiply the entire trinomial by 3. The new trinomial is not equivalent to the original. Remember to divide by 3 as a last step. So as you see here, multiplying through, you get 3 times 3x squared, negative 2 times 3, and then x, and then negative 8 times 3. Moving on, we've got 3x in the quantity squared minus 2, minus 2 or negative 2 times the quantity 3x, same thing, minus 24. Ax is 3x. Step 2, replace ax with a single variable. Let p equal ax. So as such, we can see p squared minus 2p minus 24. We've substituted p for 3x. Moving on, factor the trinomial. This is a factorable trinomial of which we again want numbers that multiply to negative 24 and add to negative 2. P minus 6 times p plus 4 fits the bill on that. In other words, negative 6 times 4 is negative 24. Negative 6 plus 4 is negative 2. Step 4, substitute ax back into the product. Remember that we set p equal to 3x. So factor out common factors if there are any. 3x minus 6 times the quantity 3x plus 4. Substituting 3x for p is essentially what's happening here. As you can see from the prior step, p minus 6 times p plus 4. Now p, of course, is 3x. And again, p is 3x, so 3x minus 6 times 3x plus 4. We continue. We can note that 3, remembering, is, well, a GCF technically of those two, but can be factored out accordingly, leaving us with x minus 2. Step 5, since you started by multiplying the trinomial by a, you must divide by a to get a product that is equivalent to the original trinomial. So, as you can see, x minus 2 times the quantity 3x plus 4. This product is equivalent to the original trinomial. Again, you must divide a from the solution that we just came up with. In effect, you can see then that the factored form of 3x squared minus 2x minus 8 is x minus 2 times 3x plus 4. And if you wanted to FOIL this, you'll find that it in fact equals this original quadratic. In general, you can use substitution to help transform ax squared plus bx plus c with a not equal to 1 to a simpler case in which a equals 1, factor it, and then transform it back to an equivalent factored form. Please go ahead and take a look at the Try It part A and B there for extra practice. We'll continue this when we're live.